Hello there, this is Haddad here again. So let's start now talking about OSPF and about areas in OSPF. As you already have seen, that OSPF is a link state routing protocol and it works inside our network. So it should be inside our autonomous system. An autonomous system is a set of routers which are under our privilege, under our responsibility. Okay? OSPF runs on the IP protocol number 89. Okay? And to be able to configure OSPF on our network, first we have to define an area, what we call it the backbone area. And here in this case it is area 0.0.0.0. That's the default backbone area on MikroTik routers. Okay? Why do we need areas? If we go back to the example that I have showed you in the previous lectures, when we have configured OSPF on routers, and we said that when we configure the OSPF, in this case, they will form hello, the neighbors, and then they will generate LSA, and then they can have the full picture of the network, each router, and then there is an OSPF algorithm running behind to be able to reach to the destination network. Okay, and I've already said that this requires a lot of CPU processing and a lot of memory. So in this case, if we look here in this area 0, you have one router, two. So that's one, that's two router, 3, 4, 5 routers, okay? 5 routers, they can do this work together inside this area, and they share LSA, they generate LSA to each other, and they have the LSDP, and then they have the SPF algorithm running, and then they can know what are the networks each router is connected to be able to reach to it. But in this case, you only have 5 routers, and that's quite easy. What if you have, imagine you have 75 routers here. Then this will take longer and longer and longer of time. What if you have 90 routers? So we have many networks, 90 routers. It takes a lot of time and a lot of CPU usage on each of the router when they want to make the SPF algorithm, okay, to be able to find the best path to the destination network. For this reason, we have created areas, or that's how link state works. There is areas. And then MikroTik have said that the maximum routers we can put inside an area is 80. So it should be anything less than 80 routers, you can leave it in one area. Now imagine you have a bigger network and you have 90 or 100 or 500 routers. And then in this case, it's very recommended that you don't go more than 80 routers on one area. And then you start making other areas, like you can see here, we have area 0.0.0.1 and area 0.0.0.2. In each of these areas, you can put up to 80 MikroTik routers. So when the calculation is happening in area 0, let's say on those routers, area 1 will, all routers on area 1 and all routers on area 2 will not enter into this calculation. The SPF algorithm will happen only inside the area itself. Same here, when the calculation is happening on area 1, area 2 and area 0, the backbone, they don't know about the calculation which is happening here. Just to limit the CPU processing and the memory usage for the routers which are inside these areas. Okay, so this is the first idea that I wanted to explain to you about areas. By default, area 0.0.0.0 is called the backbone area on MikroTik environment, okay? This is the most important area between all because it is the backbone, okay? That means any routers over here on area 1 or area 2, if they want to communicate to each other, they should pass through area 0. And any other areas that will be created later, they should be connected to area 0.0.0.0. As you can see here, area 1 is connected to the backbone area and area 2 is connected to the backbone area. Okay, so it's very important that first you create a backbone area in your network and all other areas will be connected to that area. Okay, now the name of the area, MikroTik use 32 bits as name of areas. Like you can see here, area 0.0.0.0. Okay, that's the backbone area. Remember, if you know IP address, it's similar to IP address. Okay, then it is 32 bits. That means it is 1 byte, 2 byte, 3 byte, 4 byte. Each byte is 8 bits, so 4 times 8, that's 32 bits. Okay, so when you want to put a number on the area, it should be 32 bit. Also, MikroTik allow you to put name on the area. Okay, like here, the default name of area 0.0.0.0 is backbone area. Okay, now after we have know about the areas, let's talk a little bit about the routers inside the areas. So this is the backbone area. Let's look inside of it now. You can see you have router 1, router 2, 3, 4, and 5. This router 1 is called a backbone router, or we call it an internal router. MikroTik call them internal router. Okay, I will escape now router 5. Let's see router 4. It's also an interior router. Okay, now router 5 and router 3. You can see that router 5 has one interface on the backbone area, which is this interface, and router 5 also has another interface also on area 0.0.0.1. So it has an interface on the backbone area, and it has an interface on the area 0.0.0.1. This type of routers is called ABR. It stands for Area Border Router. Okay, an area border router is a router which has connectivity between two areas. Okay, in this case, the backbone area and the area 1. So theoretically, this router, the ABR router, should have more CPU and more memory than any other routers like the interior router. And because this router has connectivity with area 0 and area 1, that means that this router goes inside the process of area 0.0.0.0 when there is a link state process happening, like generation of LSA, LSDB, OSPF calculation, and so forth, and also inside this area. Okay, so this router will leave inside his memory the topology of the two areas. Okay, same happen on router 3 here. Also, you can see he has one interface in this area and one interface in this area, and that's also is called an ABR. Okay, so we said that we have first the internal router, that's one, and then we have the ABR, the second type of routers. The third type of routers we have here is this router over here. It has an interface on the backbone area and another interface inside another network, which is in this case RIP. RIP is a routing protocol like OSPF. So this router works on two routing protocol, and in this case this router is called ASBR. ASBR, Autonomous System Border Router. Okay, that's the three types of routers we can have in our OSPF network. Type number 1 is interior router, which is the router inside the area itself. ABR is a router which is connected to two areas, backbone areas and another area. And ASBR is the router which is connected to the backbone area and another network like RIP. Now, if we want to look about ABR now, ABR, it has a good function here to make some type of summarization. What ABR can do for us, can summarize, for example, the networks which are inside this area. It can summarize them to us and inject them inside this area, the backbone area. Then in this case, instead of having, for example, if you have here 10 networks, which can be summarized by one network, okay? You know summarization, how it can be done. If not, we will see it in the lab. So instead of having 10 entries coming from area zeros inside every routing table of those routers, which will take more memory, then he will inject only one network, which is a summary of these 10 networks here. Okay, and then in this case, we have in our routing table inside the backbone area, we have only one network in the routing table. That's something that the ABR can do. We can do summarization only on the ABR. We cannot do summarization in the internal routers, okay? Now, another thing to mention here about ASBR. ASBR, as we've seen here, that it's connected to RIP. And then what ASBR can do to allow us from the backbone area to reach the network over here, you can redistribute RIP inside OSPF. That means that the routers inside the backbone area and also any other area, because at the end this router and this area can also see the backbone area and will be able also to see network injected from RIP. So when he redistribute the network from RIP, this router, he will redistribute them as OSPF. Then all routers inside the backbone area will think that that's a network in OSPF. Okay, so this is what I wanted to show you in this lecture. I hope it was informative to you, and I see you in the upcoming lectures.